A function can be expressed as y is equal to f of x, where x is the independent variable and y is the dependent variable. All values of x for a function to be defined is known as domain. We can find the domain of any function algebraically. There are some rules that have to be followed if we are finding the domain of any function in order for that function to be defined. 1. If the function is a polynomial function, then the values of x, that is the domain, can be positive, 0, or negative integer. That is, x can be greater than 0, equal to 0, or less than 0. For example, if we have f of x to be equal to x plus 1, this is a linear polynomial. So this x, the domain, will be equal to x such that x is element of real numbers. If you want to find the meaning of real numbers, you can check the description below. I will click the link there for you to understand it. Or you can say that this domain is equal to minus infinity, comma, infinity. So that is how to find the domain if the function is a polynomial function. Another one, we have f of x be equal to 2x squared plus x plus 1. This is a quadratic polynomial. So its domain, that is the possible values of x, will also be elements of all real numbers. So x such that x is element of real numbers, or domain is equal to negative infinity to infinity. So see if we have 3 cubed plus 2x squared plus x minus 1 and so on. This is cubic polynomial, so its domain, the possible values of x, will be elements of real numbers. So if we are given any polynomial function, that is those functions that are in form of this, it means that its domain will be elements of real numbers. 2. If you want to find the domain of rational, the meaning of rational is that any number that can be expressed as fraction. So a divided by b, where b must not be equal to 0. So if you want to find any function in form of fraction, let's say we have g of x divided by h of x. So this h of x, that is the denominator, must not be equal to 0. For f of x to be defined, the denominator must not be equal to 0. For example, if we have f of x to be equal to 1 divided by x. So for f of x to be defined, x must not be equal to 0. Be defined. Because we want our function to be valid, then x must not be equal to 0. That is A. B. So we have f of x to be equal to x minus 2 divided by 3 minus x. So the domain of this one will be all other values, all other numbers except 0. So x such that x is elements of real numbers is minus 0. Or you say negative infinity, comma 0, union 0, and comma infinity. It means that it could be any number except 0. 0 is not included. So here also 0 is not included, but positive numbers can be there, negative number can be there, except 0. That's the meaning. So for this one, we have x minus 2 divided by 3 minus x. So for f of x to be defined, this 3 minus x must not be equal to 0. So minus x must not be equal to minus 3. So negative cancel negative, so x must not be equal to 3. So we have to avoid where x will be equal to 3. So the domain will be, we can represent it on a number line like this. This is negative infinity, this is positive infinity. I told you that infinity is not a number, it's just a symbol to indicate that the number goes on and on, it doesn't end. So let's indicate 3 here. So we now want to represent it. You go like this, then you put open something here, then it goes like this. It means that all other numbers except 3 can be plugged inside the function for it to be defined. So the domain will now be equal to x such that x is element of real numbers minus 3. All other numbers can be plugged in except 3. Domain can also be expressed as negative infinity, comma 3, union, comma 3, then infinity. So this is an open bracket. This open bracket means that 3 is not included. So or you can still say that we have 3 less than x, then x greater than 3. So that's still our domain. That is 3 is not inclusive. All other real numbers can be plugged inside this function for it to be defined. But if you plug in 3 there, you will have, as when x is equal to 3, let's check what will happen. 3 minus 2 divided by 3 minus 3, we have 1 divided by 0. And if you have your denominator to be equal to 0, your function will be undefined. And we do not want that, so we want our function to be defined. So for our function to be defined, 3 must not be plugged inside this function. Let f of x be equal to x plus 2 divided by x squared plus 3x plus 2. Find the domain of function f of x. Solution. We know that if our f of x to be defined, the denominator must not be equal to 0. Plus 3x plus 2. For f of x to be defined, x squared plus 3x plus 2 must not be equal to 0. So let's use factorization method for this quadratic equation. We have x plus 2 multiplied by x plus 1. Then it must not be equal to 0. So if you want to know how I quickly got this one, you can check my videos in the description box. So it means that x must not be equal to minus 2 or x must not be equal to minus 1. It means that the domain will be any other real numbers except minus 1 and minus 2. X such that x is element of real numbers minus 1 comma minus 2. So we can represent it on a number line. Here is positive infinity, here is negative infinity. I have minus 1 here. We have minus 2 here. So all other numbers can be plugged in for this function to be valid except minus 1 and minus 2. So here, this one means that minus 1 and minus 2 cannot be included. So it goes like this, then it will go like this. So we can still say that the domain is equal to negative infinity, comma, minus 2, union, minus 2, comma, minus 1, then union, minus 1, comma, infinity. Find the domain of a function with a square root. That is, if f of x is equal to square root of any function, any expression. So for f of x to be defined, the expression must be greater than or equal to 0. That is, if for it will be undefined if you have your expression to be negative. If you have square root of negative 2x then plus 1 or something, so f of x, let's say, must not be equal to square root of negative. If you press this one in the calculator, it will give you math error. Like if you press square root of minus 25, it will give you math error or undefined or invalid. So this one will lead to imaginary number. It will be 5i, and we do not want our function to be imaginary or complex number. We want the function to be real valued function. So in order for the function to be defined or to be valid, that means its expression inside the square root must be greater than or equal to 0. If you find square root of 0, it will be equal to 0. If you find square root of any positive number, it will be valid. It will be valid. So that's those that we want. We do not want our expression inside the square root to be negative. That is exactly what this statement means. For example, f of x is equal to square root of x plus 2. So f of x is equal to square root of x plus 2 is defined or valid, is defined if x plus 2 is greater than or equal to 0. So x will be greater than or equal to minus 2. X must be greater than or equal to minus 2. So here we need that know that all other values can be plugged in, except that it must be greater than or equal to 0. That means if you want to draw the brackets now, it will be closed. It must not go beyond negative 2, then comma infinity. So this is our domain. How do I get that? We can use the number line. This is negative infinity. Here is, so we need minus 2. This one's supposed to be is equal to. That is, the domain will be equal to close bracket. That is, it cannot go beyond. It will be this starting from here, then upward. So let's check if we use the number line to represent it. So we have minus 2, negative infinity, and positive infinity. We say that we are taking it from here. That is greater than or equal to. So it goes like this. So we do not need anything from here. Let's check if you take any number from minus 3, minus 4, and so on. So square when x is equal to, let's say, minus 3. So the square root of x plus 2 will be equal to minus 3 plus 2, which is equal to square root of minus 1. And we do not want this one. This one will not give us real numbers. It will give us imaginary. So minus square root of negative 1 will give us imaginary number, which is I. So we do not want anything from this side. If you plug in another one, take minus 5, take minus 4, it will still give you negative square root of negative number, which we are avoiding. But if you plug in 2, minus 2 there, it will give you minus 2 plus 2, which is square root of 0. And square root of 0 is valid. It is defined. You can press it on the calculator and give you the answer will be 0. If you plug in any positive number, you are okay. It will be valid. So that is what we are trying to say. If I write d of f, it means the domain of this function will now be equal to x such that x is greater than or equal to minus 2. So that is how to find the domain of a function with square roots. So another example, find the domain of the function f of x is equal to square root of x squared plus 3x plus 2. So for f of x to be defined, square root x squared plus 3x must be greater than or equal to 0. So that is what we want to work on. 3x plus 2 must be greater than or equal to 0, and this will give me x plus 2 multiplied by x plus 1 greater than or equal to 0. So you use the number line to know those numbers that we can plug in and those numbers you cannot plug in. So here is positive infinity, here is negative infinity. So we need, with this one, minus 2, then minus 1. So let's take any number way from minus 2 till negative infinity. So let's take minus 4, x to be equal to minus 4. So when x is equal to minus 4, let's see what happened. We have minus 4 plus 2, then multiply by minus 4 plus 1. So this one gives me minus 2, then multiply by minus 3. So the answer is negative multiplied by negative, it's equal to positive. So I have positive here. That means if I take any other number aside minus 4, so let's say minus 5, minus 6, and so on, I'll still get positive. That's the meaning. So let's take any number in between minus 2 and minus 1. Let's say I take x to be equal to negative 1.5. So if I plug in minus 1.5 inside this expression, I have minus 1.5 plus 2 multiplied by minus 1.5 plus 1. So I have here, this is a 0.5, which is positive, and multiplied by this one gives me minus 0.5. So positive multiplied by negative gives me negative. So I have negative here. So let's now take another number in between minus 1 to positive infinity. Let's say when x is equal to 5, positive 5. So I have 5 plus 2 multiplied by 5 plus 1. This is positive, that is 7. Then positive 6, it gives me positive multiplied by positive gives me positive. So I have positive here. So according to this law, which says that the square root of any function or any expression must be greater than or equal to 0, that means I do not need negative, I need my answer, the expression, to be positive. The expression inside the square roots, I need them to be positive. That means I'll go for those real numbers that will give me positive answer inside the square root. So that means I'll go from here, I'll circle it, then here, circle it. I do not need this place at all. So that means I cannot go beyond this boundary. Cannot go beyond this boundary. So I can go this side, and I can also go this side, but I cannot go here at all. So the domain will now be equal to x such that x is less than or equal to minus 2, or x is greater than or equal to minus 1. So another one, the domain will be equal to negative infinity, comma, minus 2, union negative 1, comma, positive infinity. So that is how to find the domain of square roots. That is how to find the domain of any function with a square root. So in the next class, we are going to continue from where we stopped. Till I see you in the next class. Thank you and God bless you. Bye-bye.